Welcome back to section 3 of chapter 5. In this section, we're going to be looking at solving quadratic equations. So far this chapter, we have been looking at graphing quadratic functions. Now we will be graphing a little bit to help us solve, but a lot of this is going to be more algebraic than graphing. So, our learning targets for today. I can solve quadratic equations by graphing or factoring, and I can determine a quadratic function from its roots. And so we're specifically going to be using graphing and factoring. There are other methods of solving quadratics that we will be getting to in the next couple topics. And so the first method, solving by graphing. We are simply going to graph this equation. Notice we went from f of x equals to just 0 equals. Because when we're solving, we're finding the zeros. When does it equal 0? And so we make it equal to 0 if we have a function, or we might have an equation. If we do have an equation like this, to graph it, we need a y value. So we're going to replace a 0 with y, and we're going to graph this function. To do that, make a table, just like we were doing last time. So we have our table. We can find the vertex negative b over 2a. Well, that'll be negative 7 over 2, negative 7 over 2, which is 7 halves. And so we can plug that into the function and get a number. It's not necessarily a pleasant number, but it's a number. 7 halves squared, square top and the bottom, it'll be 49 fourths. And then minus 7 times 7 halves will be 49 halves. And then we can combine them. 49 fourths minus 49 halves is negative 49 fourths. Plus 6 is negative 6 and 1/4. And so we can put that in there. Now, is this a hugely important number? Not particularly. The negative 6 and 1/4, it's the vertex, but that doesn't have much to do with solving. But it gives us a starting point. Now we can go 1 in each direction. 7 halves is 3 1/2, so we can go 3 and we can go 4. And then 2 and 5. We can plug those numbers into the equation, which will be much more pleasant. And then we can multiply. So 2 squared is 4, 7 times 2 is 14, 3 squared is 9, 7 times 3 is 21, etc. We have some symmetry going on here as well. And so we can multiply those and then combine our like terms to get negative 4, negative 6, negative 6, negative 4. Move those in, and then we can graph it. Just plot our points. So we have 2, negative 4, 3, negative 6. There's our vertex, which if we miss that, doesn't really make much of a difference, because here we have 4, negative 6, and 5, negative 4. Now we are looking for when the function equals 0. The function equals 0 there and there. And so what does this look like? This looks like x equals 1 and x equals 6. And so that is a guess. Solving by graphing, just like solving systems of equations by graphing, is really just guess and check. If you're told to do it by graphing, it should probably be a fairly nice number, but it is still guess and check. So we do have to check these. We have to plug in 1 and 6 and see if it works. And there's some synonyms. Sometimes it'll tell us to find the zeros. Sometimes it'll tell us to find roots, find solutions, find x-intercepts. These all mean the exact same thing. So we have x equals 1, x equals 6. We can plug these into the equation. When we plug in 1, 1 squared is 1, minus 7 times 1 is 7, 1 minus 7 plus 6 is 0. We plug in 6. 6 squared is 36. 7 times 6 is 42. 36 minus 42 plus 6 is 0. So the answers are 1 and 6. So that's the first way of solving by graphing. It's by doing it by hand. Now that can work, but if our numbers are really, really big or really, really little, having a graph that's accurate enough to see what we're doing is very difficult when we're doing it by hand especially. And so another way, we can use a calculator to help us solve by graphing. So we can enter a graph, So we just enter into the y equals, just like we would enter any other graph, x squared minus 7x plus 6. Remember to use the minus, not the negative. And then graph it. Looks like that. Hey, that looks like what our graph over here looks like. Imagine that. And it looks like it's hitting at 1 and 6, just like it looked like it was hitting at 1 and 6 over here. And then we can go to the table. The table is the second graph button in these TIs. In other calculators, it might be different, but we can look at the table and see, and we're looking for when x equals 1 and x equals 6. So when x equals 1, y equals 0. And when x equals 6, y equals 0, which means that x equals 1 and 6. And so that's one way of using a calculator. There's also a calculate feature where you can calculate it, which is handy when the answers are really ugly. But just looking at it is a good way if the answers are going to be nice. And again, solving by graphing is guess and check. It's not usually how we're going to do it. Usually we're going to be solving by factoring. And this gets even more important in the next chapter. Even later on this chapter, solving by graphing is not going to actually get you any answers at all. So solve by factoring. So if we have the exact same equation, x squared minus 7x plus 6 equals 0, we can factor it. Now what is factoring? Well, it's like distribution. Distribution, we have x plus a times x plus b. We can multiply the x and x and b, a and x, a and b, to get x squared plus bx plus ab, which we can then factor out the x here to get a plus b times x. And factoring is just going backwards. We have this, we want to make it look like this. And so we need two numbers that will add up to give us this number, two numbers that will add to give us negative 7, that will multiply to give us 6. That's what we're going to be looking for. And so we need to have for parentheses x plus something and x plus something. So two numbers multiply to give us 6 and add to give us negative 7. What times what equals 6? 2 times 3. Are those going to add to give us a 7 or negative 7? No. If this were minus 5x or plus 5x, we'd be using 2 and 3. What else times what equals 6? 6 and 1. 6 plus 1 equals 7. Well, how would we get negative 7? With negative 6 and negative 1. So you have x minus 6, x minus 1. If we multiply, we have x squared minus x minus 6x is minus 7x. And then negative 6 times negative 1 equals positive 6. And so we factored it. Now, what good did this do us? Well, we have this thing called the zero product property. It says if you have two things multiplying together to give you 0, then one of those things has to equal 0. Because if something times something equals 0, what times what equals 0? 0 and something else. So that means that either x minus 6 equals 0 or x minus 1 equals 0. If x minus 6 equals 0, what does x equal? X equals 6. And if x minus 1 equals 0, what does x equal? X equals 1. So x could equal 6 or 1. And that's the same thing we found when solving it by graphing. All right, so let's factor another one. So here we have a function, g of x equals x squared plus x minus 6. First step, that g of x needs to be a 0. Because we need to have it equal 0. That's what we're looking for. All right, then we can factor. We need two numbers that will multiply to give us negative 6 and add to give us 1. What kind of numbers multiply to give us a negative? A negative and a positive. What happens when we add together a negative and a positive? What does it look like? Subtraction. So what two numbers will multiply to give us 6 and subtract to give us 1? There's our 2 and our 3. Which one has to be positive to make this subtraction positive? So do we want 2 minus 3 or 3 minus 2? 3 minus 2, so 3 will be positive. And so we'll have x plus 3 and x minus 2. So we have x squared minus 2x plus 3x is plus x, and then 3 times negative 2 is negative 6. If this were a minus x, we would just switch these two signs. It would be minus 3 plus 2. Right, well, we have two things equal 0. That means either x plus 3 equals 0 or x minus 2 equals 0. And if x plus 3 equals 0, that means x equals negative 3. And if x minus 2 equals 0, that means x equals positive 2. Right? So just factoring. Factoring is a skill that you did in algebra quite a bit. That's something that, like, it's not the end of the problem. It's just one little step. If you're struggling with factoring, you need a lot of practice, because factoring is something that you need to be able to do without thinking about it too hard. All right, let's try another one. Here we have 4x squared minus or equals 81. So the first thing with these, we have to get it equal to 0. For this one, we just change the g of x to 0. This one, we want to subtract, add and subtract stuff over so it equals 0. So we'll subtract 81 to give us 4x squared minus 81 equals 0. Now we can factor this just like we did these, but in this case, this is a special factor, and it's a lot easier to actually look at the formula for this special factor. And this special factor is called the difference of squares. We have a squared minus b squared. It's going to equal a plus b times a minus b. So the difference of squares, this is an important one. We have a squared minus b squared equals a plus b times a minus b. Now, here we have something squared minus something squared. What squared gives us 4x squared? That would be 2x. And what squared gives us 81? 9. So the a would be 2x, and the b would be 9. We just plug them in. So we'll have 2x plus 9 times 2x minus 9 equals 0. Now notice these are the same, except one's positive, one's negative. Because what happens when we multiply? We have 2x times 2x, that's a 2x squared. 2x times negative 9 plus 2x times positive 9, those two cancel each other out. They add to give you 0, which is 0x. And then 9 times negative 9 is negative 81. And so we have 2x plus 9 times 2x minus 9 equals 0, which means that either 2x plus 9 equals 0 or 2x minus 9 equals 0. Solve for these. Either subtract or add the 9. So we get 2x equals negative 9 or positive 9. And then divide by 2. So x equals negative 9 halves or x equals positive 9 halves. And then we can rewrite this. We could leave it like it is, or we could rewrite it as x equals plus or minus 9 halves. And so this one would be really difficult to try and graph. I mean, the y-intercept is at 81. Our x-intercepts are at plus and minus 9 halves. I mean, that's going to be a tough one to try and graph. So here, factoring is definitely a lot easier. So back to our special factors. One of them is difference of squares. That is the most important one to remember, because trying to factor it without that is a little bit trickier. The other two, which is really just the other one, is a perfect square trinomial. That's where we have the same thing squared, like a plus b squared, x plus 2 squared. And that factor, it's a squared plus 2ab plus b squared, or we can have the negative. It just switches the sign here for that negative. These ones you don't need to remember so well, because when you get it, you just factor it, and it turns out like, oh, I got x plus 1 and x plus 1. They were the same. Look at that. And it just kind of happens naturally. So these ones aren't as important to remember. So let's try a couple. So try this one. F of x equals x squared plus 4x minus 5. Factor it, solve it. So push pause and then come back when you're ready in a minute. How did you do? So let's first factor it. Well, before we factor it, we want to make it equal to 0. Then we can factor. What times what gives us negative 5 but adds to give us 4? 5 and negative 1. So we have x plus 5 times x minus 1. And so, well, if x plus 5 equals 0, that means x equals negative 5, or x minus 1 equals 0, so x equals 1. All right, how'd you do on that one? Pretty good? Hope so. Let's try another one. X squared minus 8x minus 20. Go ahead, pause, factor and solve, and then come on back. All right, so make it equal to 0. And then what times what equals negative 20? Negative 10 and 2 gives us negative 8. Well, if x minus 10 equals 0, x plus 2 equals 0, that means x equals 10 or x equals negative 2. And one last one. So try this one. We have x squared plus 25 equals 10x. Remember, first step, make it equal 0. You're going to need to subtract this one over. So go ahead, pause it, and then come on back when you're done. All right, so we move the 10 over. We get x squared minus 10x plus 25. We need to factor what times what equals 25? 5 and 5, or negative 5 and negative 5. So we get x minus 5, x minus 5. Well, x minus 5 equals 0, or x minus 5 equals 0, which means x equals 5, or x equals 5. That's the same thing twice. We don't need to repeat it. It's just x equals 5. And notice up here, we had the same factors. So this could have been written as x minus 5 squared. This was a perfect square trinomial because it came out to be the same thing twice. Did we need to know that? No, we just factored it, and then it's like, oh, hey, look, what happened? That's why these ones aren't quite as important to just have in your head. And so that's the second method, solving by factoring. Set it equal to 0, factor, and then solve for each of those two factors because one of them will have to equal 0. And the last thing we have is writing a quadratic function from its roots. This is just going backwards from what we've been doing. We have the roots, the zeros, the solutions, the x-intercepts, x equals 2 and x equals negative 3. Well, if we know x equals 2, what would have been a factor that got us x equals 2? That would be x minus 2 equals 0. So one of our factors is x minus 2. Then x equals negative 3, that would be x plus 3 equals 0. And then we need an equals 0. Don't leave this off. That's part of not being sloppy. Keep it on. It will help save trouble in the long run. So this is our quadratic equation. It'll tell us it needs to be in standard form, so we just need to multiply it out. So we need to distribute. X times x is x squared. X times 3 is plus 3x. Negative 2 times x is minus 2x. Negative 2 times 3 is negative 6. Equals 0. Then just combine our like terms in the middle, 3x minus 2x. We get x squared plus x minus 6 equals 0. This is a quadratic equation. It wants a quadratic function, so we just need to change the 0 into an f of x, g of x, h of x, y. I'm going to go f of x. So f of x equals x squared plus x minus 6. That would be writing a quadratic function from its roots. So we have solving by graphing, solving by factoring, which is the more important of the two, and then a little bit of going backwards. We have the roots, write the quadratic function from those roots. So this is what section 3 is about. We'll continue moving on with solving quadratic equations in the next few sections. I'll see you then. Until then, happy mathing.